Hi students. Okay, today we are discussing the topic is symbolic operations, the basic definitions. Okay, na? Okay, in the already discussing the previous lecture, the Newton's forward, backward, and central Gauss forward and backward, and also Lagrange's. So here basic formula is definitions are given. That is a forward operator, backward operator, and the central operator. How to defining the basic definitions? Okay, na? See that here. First, forward difference operator is the first order forward difference operator is denoted by del. Already I told the forward operator is denoted by del. So that is it's a del. So that is equal del f of x is equal to the difference between function value before value minus the backward value. So that is f of x plus h minus f of x. X plus h next value కదా, x తర్వాత వస్తుంది, x తర్వాత x plus h, h is just step length. The function value is the difference f of x plus h minus f of x. This is the first order difference operator. So similarly second order is difference between first order, that is del square f of x is equal to del f of x. Del f of x and here f of x plus h minus f of x, that is equal to again del f of x plus h means the next value x plus h తర్వాత x plus 2h కదా, అంటే del f of x plus h అంటే f of x plus 2h minus f of minus x plus h కదా. సో similarly del f of x అంటే మళ్ళీ f of x plus h minus f of x, both are same కాబట్టి adding 2 into f of x plus h plus f of x. This is the second order. Okay, this is the forward difference operator. So next one, backward difference operator. The first order backward difference operator is denoted by Namala. Is denoted by and defined as Namala f of x is equal to f of x minus x minus h. X minus h అనేది బ్యాక్వర్డ్ కదా, అంటే xకు ముందున్న వాల్యూ. నెక్స్ట్ ఏమో x ప్లస్ హెచ్, ఎక్స్కి బ్యాక్వర్డ్ ఏమో x మైనస్ హెచ్ కదా, అంటే f of x minus f of x minus h. This is the difference. So difference same but denoting different. Is the del is Namala. Okay. So similarly we define the second order. So Namala f of x, that is equal to Namala f of x minus f of x minus h, that is equal to f of x minus 2 into f of x minus h plus f of x minus h. This is a second order backward difference operator. Okay. So next continuation the definitions. So central difference operator. The first order central difference operator is denoted by delta. Delta is the central difference operator. So delta is equal to half of కదా, మిడిల్ లో యావరేజ్ తీసుకుంటాం. సో del f of x, delta f of x is equal to f of x plus h minus f of x minus h. చూడండి ఇక్కడ x by 2, ద నెక్స్ట్ వాల్యూ x minus h మిడిల్లో తీసుకుంటాం. అవునా, h అనేది మిడిల్లో కదా, హాఫ్ ఆఫ్ ఏం తీసుకుంటాం, f of x plus h minus f of x minus h by 2. So that is delta f of x is equal to f of x plus h by 2 minus f of x minus h by 2. The difference is also same అండి, but denoting is the different, that is central కాబట్టి మిడిల్లో తీసుకుంటాం. సో this step length h. This second order delta square f of x is equal to delta into delta f of x. So that is equal to same. So f of x plus h minus 2 into f of x plus f of x minus h. This is the second order central difference. Okay. So next mean average operator. Mean or average operator. That is equal to the first order mean operator is denoted by mu. This operating is mu and this is average operator. So is defined as mu f of x is equal to, that is children, average f of x plus h by 2 plus f of x minus h by 2 by 2. This is the function value చూడండి, average we are to choosing both values. This is observing here, this is the forward, this is the backward observing. that is the average of both values, that is the mean or average operator. Okay, so next one, shift operator. Shift operator is denoted by the first order shift operator is denoted by E, capital E, and it is defined as E f of x is equal to f of x plus h. అంటే షిఫ్ట్ ఆపరేటర్ అంటే షిఫ్ట్ అవుతుందండి, అంటే ఫ్రమ్ వన్ వేరియబుల్ టు ద నెక్స్ట్ వేరియబుల్ షిఫ్టింగ్. ఇక్కడ చూడండి ఎఫ్ ఆఫ్ ఎక్స్ కదా, ఎక్స్ ఈజ్ ద వాల్యూ, నెక్స్ట్ వాల్యూ ఏంటిది స్టెప్ లెంత్ విత్ యాడింగ్ ద స్టెప్ లెంత్ ఎక్స్ ప్లస్ హెచ్, అంటే ఎఫ్ ఆఫ్ ఎక్స్ ఈజ్ షిఫ్టెడ్ టు ఎఫ్ ఆఫ్ ఎక్స్ ప్లస్ హెచ్. నెక్స్ట్ f of x plus h shifted to next value f of x plus 2h, అంటే షిఫ్టింగ్ వన్ నుంచి నెక్స్ట్ వాల్యూ నుంచి నెక్స్ట్ వాల్యూకి షిఫ్టెడ్. దిస్ ఈస్ కాల్డ్ షిఫ్ట్ ఆపరేటర్ ఈజ్ డిపెండ్ యాజ్ ఈ ఎఫ్ ఆఫ్ ఎక్స్ ఈజ్ ఈక్వల్ టు ఎఫ్ ఆఫ్ ఎక్స్ ప్లస్ హెచ్. సో సిమిలర్లీ సెకండ్ టూ టైమ్స్ షిఫ్టింగ్ అండి, ఈ స్క్వేర్ ఎఫ్ ఆఫ్ ఎక్స్ ఈజ్ ఈక్వల్ ఏమవుతుంది ఎఫ్ ఆఫ్ ఎక్స్ ప్లస్ 2h, అంటే టూ టైమ్స్ షిఫ్ట్ అవుతుంది h టు h. సిమిలర్లీ n time shifted, e power n f of x is equal to f of x plus nh. చూడండి n time shifted అంటే n is equal 1 2 3. So this is the shift operator. So next one, so e power minus n అంటే బ్యాక్ షిఫ్టెడ్, ఇదే ఫ్రంట్ షిఫ్టెడ్, ఇది బ్యాక్ షిఫ్టెడ్, అంటే e power minus n is into f of x is equal to f of x minus nh. This is the front shifted, this is the back shifted. So next one, so next relation between the operators. So del, nabla, delta, mu, e. So this is the important questions, the short questions only. Okay na, relation between all operators. First one, del is equal to e minus 1. The first relation, del is equal to e minus 1. So we know that del operating, del f of x is equal to f of x plus h minus f of x, the known definition. Okay na, but f of x plus h can be write the using the shift operator కదా, f of x plus h is equal to e f of x, అవునా చూడండి, by using the definition of shift operator f of x plus h is equal to e f of x minus f of x. So f of x common, e minus 1 into f of x, so we have to cancel f of x, therefore del is equal to e minus 1. This is the first relation. Okay, so next second relation, nabla is equal to 1 minus e power minus 1. So that is equal to nabla is a backward difference. Nabla f of x is equal to f of x minus f of x minus h. So that is equal to f of x back shifted, e power minus 1 f of x is equal to f of x minus h kada. So that is equal to e power minus 1 f of x common, 1 minus e power minus 1 f of x cancel, nabla is equal to 1 minus e power minus 1. Okay na. So next one, delta is equal to e power 1 by 2 minus e power minus 1 by 2. This is the next relation. So by using the delta is the central operator kada. So that is equal, using the definition of central operator is delta f of x is equal to f of x plus h by 2 minus f of x minus h by 2. So observing here f of x plus h by 2 shift operator చూడండి, ఇక్కడ h coefficient 1 by 2, అంటే n is equal 1 by 2 కదా, అంటే e power 1 by 2 f of x minus e power, here n is equal minus 1 by 2, e power minus 1 by 2 f of x. So f of x common cancel, therefore delta is equal to e power 1 by 2 minus e power minus 1 by 2. Okay, understood the basic relations? Yeah, remaining relations. So mu is equal to e power 1 by 2 plus e power minus 1 by 2. See that mu is the mean operator here, average operator. So that is equal to here mu f of x is equal to f of x plus h by 2 plus f of x minus h by 2. So using the here same shift operator, that is equal to e power 1 by 2 f of x plus e power minus 1 by 2 f of x by 2. That is equal to e power 1 by 2 f of x common. On both sides f of x cancel. Mu is equal to e power 1 by 2 plus e power minus 1 by 2 by 2. Okay. So next one, next relation, e is equal to e power hd. Okay, d is a differential operator, d by dx. So h is a any value, step length value. E is equal to shift operator. So since e f of x is equal to f of x plus h by definition of shift operator. So f of x plus h can be expanded by using the binomial theorem formula. F of x plus h can be expanded, that is equal to Taylor's theorem by expansion by binomial theorem. So by using the Taylor's theorem, f of x plus h into f dash of x plus h square by 2 factorial f double dash of x plus up to so on. So this is expanding in binomial theorem and using the Taylor's theorem formula. This is a formula for Taylor's theorem. So that is equal to here, which is can be right, f dash of x means df of x, f double dash of x means d square f of x. F of x common the f of x common 1 plus here h into d plus h square by 2 factorial into d square plus up to so on f of x. This is f of x common. So on both sides f of x cancel. E is equal to, this is expansion of e power x kada. E power x expansion 1 plus x square by 2 factorial plus up to so on kada formula. So that is e power x. X is equal to h by d. So e power hd. Okay, now this is a relation between all difference operators. Okay. So this is the identities, remaining formulas and relation between all identities. See that the first one, second one, third one, fourth one, fifth one, sixth one, seventh one. So similarly we have to showing the previous relation. We would same, we can prove that one. Okay, na? This is another identities. Okay. So next one, so properties of difference operators. Delta k is equal to 0 and del means operation difference operator. So that is del k is equal to 0. K is any constant. The derivative of k and mod, that is a numerical differentiation. That is k is equal to 0. Next to del of a into f of x, that is a into del f of x, and a is a constant outside of the differentiation, a into del f of x. So del of a into f of x plus or minus b into g of x is equal to a, b is a coefficients outside, a into del f of x plus or minus b into del g of x. Next to del of f of x into g of x, the product of the two functions differentiation only. So that is f of x plus h into del g of x plus g of x into del f of x. This is a formula product. Next to division of two functions, del of f of x by g of x is equal to g of x into del f of x minus f of x into del g of x by g of x into g of x plus h. So next to factorial notation, a product of the form x into x minus 1 into x minus 2 into up to so on x minus r minus 1 is called a factorial and is denoted by box x power r, and a product of the all x value minus its numerical number. అంటే x minus 0 into x minus 1 into x minus 2 up to r minus 1. So this is a called factorial notation. It is denoted by box x power r. Your box x power 4 అనుకోండి ఏమవుతుంది x minus 0 into x minus 1 into x minus 2 into x minus 3 అండి. బాక్స్ x power 4 అంటే 4 అంటే బిఫోర్ 3 వరకు మనం మైనస్ చేసి ప్రొడక్ట్ చేస్తాం. దిస్ ఇస్ అ ఫ్యాక్టోరియల్ నొటేషన్. సో దట్ ఈస్ box x power is equal to, we are right, x into x minus 1 into x minus 2 into up to so on x minus r minus 1. So del power box xn is equal to n factorial. So box x power n కాబట్టి ఓన్లీ nth ఆర్డర్ డిఫరెన్షియేషన్, దట్ ఈస్ n factorial. నెక్స్ట్ డిఫరెన్షియేషన్ ఏమవుతుంది, n plus 1 n plus 2 డిఫరెన్షియేషన్ ఆటోమేటికల్లీ 0 అయిపోతుంది కదా, ఎందుకంటే nth ఆర్డర్ ఇస్ కాన్స్టెంట్ కాబట్టి నెక్స్ట్ కాన్స్టెంట్ డెరివేటివ్ 0. సో ఆల్ ఆర్ 0 అంటే h is equal స్టెప్ లెంత్ ఈజ్ చూసింగ్ 1. ఓకేనా, ఎందుకంటే డిఫరెన్స్ చూడండి x నాట్ x minus నాట్ x minus 1 x minus 2 డిఫరెన్స్ అన్నీ కూడా 1 కదా, 0 1 2 3 up to so on. The step length is only 1. So next fundamental theorem of finite difference. So if f of x is a polynomial of degree n, then nth order difference f of x is constant, and n plus 1 n plus 2 up to so on order difference of f of x is 0. So అంతే కదా, we have to finding the only differentiation of the same order. సో ఇప్పుడు nth డిగ్రీ పాలినామియల్ అనుకోండి, we have to differentiation only up to nth డిగ్రీ. నెక్స్ట్ డిగ్రీ డిఫరెన్షియేషన్ ఏమవుతుంది ఆటోమేటికల్లీ 0. దిస్ ఈజ్ అ ఫండమెంటల్ థియరమ్ ఆఫ్ ఫైనైట్ డిఫరెన్స్. సో నెక్స్ట్ we can form a polynomial of degree at most n if given n plus 1 table values. So already I told in the previous lectures, given table values n plus 1 values ఇచ్చారనుకోండి, we have to finding only degree of nth degree polynomial. We cannot finding n plus 1 degree, that is less than 1 value. ఇప్పుడు n ఇచ్చారనుకోండి, ఫర్ ఎగ్జాంపుల్ టేబుల్ వాల్యూస్ 5 ఇచ్చారనుకోండి, ఓన్లీ we have to finding of degree polynomial only 4 or 3 or 2 or 1. 10 ఇచ్చారనుకోండి టేబుల్ వాల్యూస్, we have to finding the degree of polynomial is 9th degree or 8 or 7 up to so on, but cannot exceed more than n. That is fundamental theorem of finite difference. Okay na? So this is the basic definitions and the theorems. Okay, thank you. This is the basic definitions and some formulas and definitions. Okay, and also relation between all differentiation. So for more videos, please do subscribe my channel, like and share it. Thank you.